Dear students, now we are going to do the exercise of the specific factor models. So we are going to start with the first one. In the exercise 1, you have one economy that is able to produce two goods, the good 1 and the good 2. For producing the good 1, you can use labor and also capital. So that industry is the production factor that is specific of that industry is capital, while for the other case is land. We also know that the total labor in this economy is 100 units of labor. Now we are going to do the first part of the exercise in which you have to draw the production function in each economy, in each good. To do that, you have to use this kind of graph where here we have the input, that is labor, and here you have the output, so the production. In this case for the good 1 and in this case for the good 2. You have that information in the table, so the only thing that you need to do is more or less do a graph. You are going to see that the slope of this new function that you are going to get is not going to be constant. Instead of that, it's going to be positive, so that means if you increase labor, also you are going to increase the output, the production, always, but that increase is decreasing. So if you see at the beginning, when you introduce 10 units of labor in this good, in the production of this good, your output is increasing 25.1 units. But if you add 10 labor more, the increase is going to be smaller. You can see that this difference is smaller than the 25.1 unit that was generated by the first 10 workers. Something similar is happening in the other industry. So the first 10 workers were really productive, while the second 10 workers are not so productive as the first one. So the production is increasing, but it's not always in the same proportion. In fact, it's in a decreasing proportion. That is connected with the fact that given here that capital is constant and here that land is constant, if you just add one of the production factors, which in this case is labor, those resources that are fixed are going to be shared for these workers. So adding more workers doesn't mean that you're going to produce always in the same amount, in the same proportion. In fact, here workers have to serve the machines, and here workers have to serve the land. So the productivity of the new workers are decreasing. Okay, those increases of productivity now are lower than before. That's why the output is going to be in this way, with this kind of shape. Now we're going to do the PPF curve for this economy, using the information that you have in the table. Now, to do the PPF curve, we need the information that is in the table. In fact, I just changed a little bit the order of the data that is in that table. You must remember the PPF is when you are using all your resources. So that means when you are using the whole capital that you have, the whole land that you have, but also all of the workers that you have in your economy. Here, that amount is 100. So that's why I know that the combination of output of production is coming from the fact that you are using all your workers that are in total 100. So that's why I changed the order of the table. This part is the same. I didn't change that part. But the new part is this one. I just invert the order of the data. Why? Because I want to have all the time the total number of workers that is in your economy. You can see that here the number of workers in the industry 1 is 0, while in the other one is 2. So it's 100. So in the other industry, in industry 2 is 100. So you are using the total output. So that means that when the total labor in the industry 1 is 0, your output is 0, that involves the fact that you are just producing one good, and that good is the good 2, where the total labor is 100 that are producing 100 units. Where is that point in this graph? Well, it's when your output in the production Q1 is 0 and your output in the industry 2 is 100. So here I'm going to put the output for the good for the industry 1, here for the industry 2, and that point is when this is 0. You must keep in mind that in the vertical axis is the quantity of the good 1, 0, so that means in this point, this value, while the horizontal is going to be the output in the industry 2, which is 100, so it's this point A. Now I'm going to consider another point. That one is going to be in the case in which you are using 10 units of labor in the industry 1, so that means you are going to use 90 units in industry 2 because you want to get what is the total output when you are using all your resources. And here is labor as also, which is 100, so 10 plus 90 is 100, so that means you are using all your resources. In that case, your output in this industry is 25.1, while in the other is 95.9. Where is that point? It's going to be here, in the point B. So you can see that in this case, the amount of output in the case of the good 2 is quite big. You see, really close to the 100. In fact, it's 95.9 units is this one, while you are producing less for the other sector, so it's 25.1 units, which is more or less here. Okay, I'm going to try to separate this one in order to get here more space to introduce the other one. Okay, so what's going on for the point C is when you are using 20 units of labor in the good 1 and 80 in the good 2. In that case, your output for the good 1 is still small, is 38.1 units, while in the good 2 is 91.4. So is the point C something like this, okay? So you have those data here. Then you can do it for the other, for all the combinations. When you do that, you are going to realize that the actual shape of the curve is going to be something like this. So I already know that that is going to be the shape. Why? Because we are in a context of the missing returns in the case of the labor. So when you just introducing labor and the other production fraction is fixed, that means that the productivity of labor is diminishing. So that makes that the opportunity cost of producing more of the good that you are already producing is increasing. And you can see that because the slope of this PPF is not constant. So instead of that, if you remember, the slope of this curve is the opportunity cost of producing this good, right? And the inverse is going to be for the case of the other goods. You can see that the slope at the very beginning is very flat, but then it's increasing. So that means when you are increasing the production of the goods too, the opportunity cost of producing that good is increasing. The slope is steeper. You see, something like that. So the opportunity cost is higher and higher when you are producing more and more of that good that you are already producing a lot. That was because that labor that you need is a huge amount of labor just for producing 1 unit more, because they are not really productive. And the opportunity cost is the fact that all those new workers that you introducing in that industry could be in the other one where the production was higher. So that's why it's in that way. Okay, so let's continue with the exercise. Now we are going to do the exercise 2. This exercise is also based in the same information of the previous exercise, so it's just a continuation. The new thing that we have is also we have information about the marginal products of labor in each good. You can see, just look in the table, that is decreasing. So that means at the beginning, the marginal products of labor for the first workers is higher than at the end, for the last workers that you are introducing. Now we need to say where is going to be allocated the labor. So how is going to be the amount of workers in the good 1, in the production of that good, and in the good 2. Okay, also we know that the relative price of equilibrium is equal to 2. So this is the information that we have. And also we have the table that you saw in the exercise with the marginal productivity of labor for each industry. We know that if we are in an equilibrium situation, that means that wages in both industries are equal. So that means that if wages is also the value of the marginal production, that is the same as saying that the wage is the price of the good and the marginal products of labor. So it's like my wage depends on the good that I'm producing, but also in the productivity that I have. And so if this is equal, it's because this value has to be equal to this one. So after we rearrange this data, we can get this relationship. So the ratio of prices has to be also equal to the inverse ratio of the marginal products of labor. So this is an equilibrium condition. And in this case, it must equal the number 2. Okay, so now the thing that we need to do is getting the allocation of labor in each industry when this ratio of marginal productivity is equal to 2. That's why I'm going to use the information that I have in the exercise, but one more time I'm going to change a little bit the order. So this part is going to be the same. So you have here for the labor for 10 workers, the marginal productivity for that industry, for that number of workers, then for 20 and so on. And now I'm going to do the same but for the other workers, but just changes the order. So if this is 10, we are in a context of PBF, so you are using all the resources that you have. In this, if this industry is using 10, it's because the other one is using 19. If this industry is using 20, it's because this is using 80, and so on. So that's why this is in a different order. Now, the thing that I have to do is looking the marginal productivity for each case, make the ratio, and then find that combination that gives as result number 2. So here I have this number, this marginal products of labor for the industry 1, divided to this one, which is this value. Okay, so this is the ratio of these two elements. I'm going to do that until a point in which that ratio is equal to 2. So that is going to be the combination of labor, which is in an equilibrium. So that means I have for the industry 1, 30 units of workers, while for the industry 2 is 70. I already know more or less the results. That's why when I was drawing my curve, I put the equilibrium in a point like this, where this is smaller than this, because this is going to be the amount of workers in the industry 1, while this is the amount of workers in the industry 2. Just remember that this is the demand of labor for the industry 1, while this is the demand of labor for the industry 2. You already know why it's in this shape, so that's why I'm not going to repeat that. So, answering this exercise, here we are going to have these 30 units of worker for the industry 1, and this is going to be the difference, the 70 units of worker for the industry 2. Now, in the part B, the thing that we have to do is to prove that the opportunity cost in that point is close to 2, which was the ratio of prices. I mean, the relative price of the good 2. But before of that, I forgot to tell you what is the wage of equilibrium. It's going to be here, of course. So I was talking about the labor allocation, but in that point it's going to be the wage. So to get that proof, we need to calculate the opportunity cost of producing this good. okay? And that must be around that equilibrium point where the units of labor, so between the bracket is going to be the units of labor I'm using in each point, okay? So in this case, for this output, we know that we are using 30 units of labor for the good 1 and 70 units of labor for the good 2. This is the output that is coming from the first table. To get the output, to get the opportunity cost is just having an approximation of the slope around this point. So for doing that, you can use two options here. One of them is considering the previous points. So when the labor that you are using in the output 1 is 40 units and in the output 2 is 60 units, so this is when you are increasing the output of the good 2, that is the best way probably. Or also you can use the next point around to this equilibrium one, when you are using more of this good and less of the other goods. In both cases, the result is going to be an approximation. Never is going to be a perfect 2. Why? Because we are considering points very with a big distance between them, and the slope is in just one point. Just keep in mind that the slope is changes in each point. When we are going to try to get that opportunity cost, it's going to be the slope between these 2 points. So it's not just the slope here. Here is going to be a little bit smaller, while here between these 2 points is going to be a little bit higher than the number 2. But with that is enough. So I'm going to consider the information of this point. So that means when instead of using 30 units of labor in the industry 1, you're using more, 10 units more, and 10 units less in the second one. So to get the slope, which is the opportunity cost, is always the variation of this variable divided the variation of the other one. Because we know that it's going to be negative, it's opportunity cost, we are going to use that difference. So the variation is how it changes, so it's the difference. In some cases it's going to be positive, in the other it's going to be negative, because this is a trade-off. If you want to produce more of one good, you have to produce less of the other. So one of them is going to increase the quantity while the other is going to decrease, so that is negative. But we are going to consider in the absolute terms of this difference. That's why it doesn't matter. We are not going to have that problem. Always keep in mind that normally we use final value minus initial one, final minus initial one. In this case, because we are using the absolute terms, it doesn't matter. Because that is going to, the change of this, the only thing that is going to change is the sign. Sometimes it's going to be positive, sometimes it's going to be negative. But because we just want to know the difference in absolute terms, the sign, it doesn't matter. So it's not really important if you just make just the opposite, okay? So variation of the output 1 is, I am starting from this point, for instance, it doesn't matter, as I said. I can start here and go here, or start here and go here, or start here and go here. It doesn't matter. The thing that I want to know is how to change the output of the good 1 when I change the output of the good 2. And then I know how much change this production when I increase 1 unit of this one. It's like, yeah, I dividing the total deviation respect to the other one. So it's how it's going to change this when this is increasing just 1 unit. So in the case of the output of the good 1, it was, for instance, this value, because here is the output 1, and now it's this 1. So that is going to be the difference, okay? So final value is this 1 minus initial 1. Final minus initial. What about the other one? Final is this one, 86.7, and the initial was this one, because here is the production of the good 2, 81.5. So that's why I have the difference. As I said, you can make the opposite and it doesn't matter. And the result is not 2, but it's really close. It's 1.75, because in fact you are getting this slope. Also, you can do the same, but using the information when the labor is 20 and 80. And you are going to have two values here, and then you can make how change this divided by how change the other one. So between here and here it's really small, that's why I didn't do it. And then you're going to get opportunity cost of 2.2. I'm saying that just in the case that you want to practice, you can do it, and you have to get the results. So you are going to get the output for the good one in this, when the labor in that industry is 20, and put that. Then the output of the good 2 when the labor is 80, and then the thing that you have to make is how change this output and how change this output respect to this one, okay? Respect to this point. And then you're going to get that 2.2. Now we are going to do the part C. What is the new part here? The thing that the relative price changes. Now the ratio of prices, instead of being 2, is 1.3. That can be for 2 or even 3 reasons. This is smaller than this. That can be because this number now is smaller than this, or because this is higher than this one, or both things at the same time. Because the results are not going to change depending on which decision you have regarding to assuming which is the kind of change. We are going to consider the easy one. Let's say that this number now is smaller than before. As I said, you can do many combinations. You can assume that this is smaller, or this is higher, or both of them, this is smaller and this is higher at the same time. But the result is the same. That's why we are going to choose the first one. We are going to assume that the new price, that's why I'm using the prime line here, because it's the new one. The new one is smaller than the previous one. That is the reason why this new ratio is smaller than the first one. So we have to repeat the previous exercise, A and B, I think. So for the A case, we need to find the location of that labor, given the new ratio of prices, given the new relative price of the good too. So I'm going to go back to that table that I was elaborating. I'm adding more values, but I stop it in this number. When I'm using 50 units of labor in the good 1 and 50 in the good 2, because the division of the marginal products of labor in the case of 1 divided by the case of 2 is equal to 1.3, which is this one. And I know that this ratio must be equal to this one in the equilibrium. Now, well, I already know that the output associated with this new division or allocation of labor is this one, okay? I've got this information from the first table, because in that one I have how is the output for any number of labor in its industry. Now I'm going to go here and find the new allocation of workers. In fact, the thing that I have is that the price of the good too now is different. More specifically, is smaller. So that is going to have an effect in the demand of labor in that industry. Because if you remember, the wage is also equal to the price of the good times the marginal products of labor in that industry. Now the price is smaller, so it's not this anymore. That means that the whole slope, because this is wage and wage is in the vertical, so it's going to be a little bit down. It's going to decrease, and decrease 0 is here, closer to 0. It's because you are decreasing that weight. Let's put a point like this. Here is going to be the new price, and the marginal products of labor, that function is the same. Where is the new equilibrium? Here. And I know that this number is going to be 50, because that is the labor associated with the new equilibrium, and the other also is going to be 50, okay? Just to refresh, how is the adjustment from this point to this one? So this was the equilibrium wages at the beginning. in both places, I mean in both industries, was the same weight. But for a while, given this new circumstance, I know that in the sector 2, the weight was smaller, this one, while in the sector 1 was higher, this one. So for a while, we have that gap. But because of that, there are going to be workers that instead of being in industry 2, they are going to the industry 1. So they are going to be here in this industry. It's going to increase. But as higher is the amount of workers, so in the horizontal we have the number of workers, right? Lower is the marginal productivity of them, so the wage also is going to decrease. That's why it's like moving around that curve. We're moving around the curve when the changes of one variable that is here is having an effect in the other variable that is in the other axis. Just keep in mind that here, in fact, we have all the possible combination of wages given the amount of workers in that industry. So, as higher is the amount of workers in the industry 1, lower is going to be the wage that is supplied in that industry. Until we get this point, which we already know that is going to be the equilibrium, when again wages in both industries are equal. So you can see that this distance, the distance between one curve and the other, is how the price changes, which is this amount, while the actual change in the weight is not so high, it's going to be smaller. We were here, and now we are here, so these small lines correspond to the change in wages. So for the next part of the exercise, we are going to talk about how is the distribution of income after this shock in the price of the good too. Now we are going to study the implication of this change of prices in terms of the distribution of income. As we observed previously, the change of the price of the good too is this one. That price is decreasing these amounts. Instead, the wages in that economy, which are decreasing, they are decreasing in a smaller amount, something like this. Just so let's refresh. How was the production of each good? For the production of good 1, we need capital and labor. And in the case of good 2, it was land and labor. So that means that here are the owners of capital and here the owners of land. Let's see the changes. So the price 1, we have shown that is constant. The price 2 is the one that is decreasing. And wages also are decreasing, but in a smaller amount than prices. Where is going to be the winners? For sure, the capital owners. Why is that? Because the prices that they are charging are the same, and they have to face lower wages. The losers, by sure, the owner of land. Why? Because the price of that good is decreasing even more than the wages. So even the good thing that you are facing lower wages, the bad thing of this is you are charging even lower prices. So it's not really good. And what about labor? So it's not really clear. It's going to be ambiguous. Because instead of just looking wages, because if you just look wages, they are going to be better off, right? But the interesting thing is not just looking the nominal wage, it's looking the real wage. So it's when you are considering the wage, but also the prices. And you get the real wage when you are dividing the nominal wage by the prices. So when you are observing this wage respect to the price of the good 1, you can see the wage is smaller, but the price of the good 1 is the same. So these workers are losing the purchasing power, their wages. While in the other case, when these workers are buying the good 2, though they have lower nominal wages, the price of this good is even lower than before, and that proportion is higher than the reduction of the wages. So when they're buying this good, they are going to be better off. It's not really clear. Here we didn't say why this price is changing, but one of the reasons could be international trade. So here, by doing this exercise, we also know how it's going to be or what is going to be the implication of international trade. Because the price of goods too now is lower than before, it's like assuming that the other economy is more competitive producing that good. That's why that economy is producing a lower lower prices, and the new international price of the good too now is smaller than the price that was in this economy when this economy was closed. Okay, so all this analysis, the good thing of it is also valid when you are studying the implication of international trade. Because if you remember, you are going to have changes in this ratio of prices. So here we have the whole analysis when you already are having that kind of changes. For doing the exercise 3, the only thing that you have to do is revisit the slides or the explanation about the increase of capital in one economy. You have that in the chapter that is specific for this model. So the chapter of the specific factor model, when the capital increase, that is going to be the whole exercise 3. The same idea, okay? So you can do it. And for the exercise 4, you can see that that is the same as when in the theory we were talking about the implication in terms of the allocation of labor in the case in which the price of one of the goods just changed. This case, I think, increased. So you have the same conclusion. You have to draw the graph for the labor market, and also you can do the same analysis with the PPF. You know that the ratio of prices is going to change, so that means a new point in the PPF, because that slope of the ratio of prices is new, is different, and also a change in the labor allocation, because one of the curve of the demand curve is going to change given the fact that the price of one of the goods is going to rise, I think. So you are going to see the implication of that in that part of the chapter, the specific factor model, when one of the prices of the two goods changes.